Welcome, everyone. My name is Mark Seefts. I'm the Director of Development for Apex. Today, we're going to have Todd Bottger talk about Vanity URLs on Autonomous. And before we get started, though, as usual, we start with a few announcements and updates. 2 weeks ago, we released Apex 21.2 on premise for download on OTN. And on the same day, we also had our part 2 of our last Apex office hours on 21.2 new features. We talked about progressive web applications, the new page layout options, improvements to the universal theme, and enhancements to geocoding and spatial. The recording of that office hour is now available, so you can go to apexoracle.com/office hours and watch the recording of both sessions if you missed any of those. Our next office hours will be in 2 weeks on December 2nd. We're going to talk about Flows for Apex. Flows for Apex is an open source workflow solution that you can use to build and model BPMN style workflows. So Niels Dibron and the Flows for Apex team are going to talk about that tool. Also next week, we're going to have the Australia Apex Developer Day. Then from November 22nd to December 7th, we'll have the Asia Pacific Groundbreakers virtual tour. And then on November 29th and November 30th will be the UK OEG Together 2021. That will be mostly in-person event. A few virtual sessions will be happening as well. Thanks for keeping an eye. I'm both going to do a virtual session. And then on December 1st and 2nd, the Oracle Database World Asia will take place. All right. So before we get into the Vanity URL update, we have Stephen Feuerstein on the call today, and he's going to tell us a little bit about Apex D2D. Stephen?
Thank you, Mark. Hey, everybody. Stephen Feuerstein. So first of all, I'm so honored to be on Apex Office Hours. I believe it is my first appearance. I helped start the program when I was back at Oracle, and it seems like it's worked out really well for many organizations inside Oracle, especially Apex. So great to see it continuing. So Apex D2D, very simply, is another way for Apex developers and Oracle database developers to get help. So we live in a new era in many ways. The pandemic has forced us to avoid traveling. Climate change is insisting that we avoid traveling, yet we still want that intimate, direct, personal connection with other people. And we often need to get our problem solved more quickly than, or more easily than is possible through Stack Overflow exchanges and Slack and so forth. So we've put together, we being INSOM, FOX, MTAG, and United Codes, 4 prominent Apex consultancies, have put together a website, which we're in the process of finishing. If we weren't using Apex, we'd never have been able to do this in the amount of time we're doing it with a small volunteer team. Anyway, on November 30th, you'll be able to have one-on-one 30-minute sessions with many Oracle database and Apex experts, including 20-something people from the Apex team itself. So starting Tuesday next week, go to apexddd.net, and you'll be able to register, reserve a session with an expert, and then on the 30th, have those one-on-one sessions. I think that should do it. Thank you, Mark. Thanks for the support from the Apex team.
No, thank you. Thanks for organizing this, and thanks for joining us today.
All right. Take care, everybody.
All right. Then next up, we have Todd. Todd, all yours.
Okay, great. So my name is Todd Bottger, and I'm a PM director here in the Oracle database team. And we'll be talking about Vanity URLs for Apex and ORDS on Autonomous Database. And first of all, to define Vanity URLs, we're basically talking about setting up custom domain names. So Vanity URLs is kind of our nickname for that. And what I'm going to talk about here will be broadly useful to, I think, anyone who's interested in Oracle Cloud, Oracle Autonomous Database running in Oracle Cloud, and particularly useful for folks who are looking to set up custom domain names on top of Oracle Autonomous Database running in Oracle Cloud. So we'll be getting into a fair amount of cloud stuff here. And if any of that is of interest, then this presentation is for you. Okay, so just to kick this off, there's a bunch of web technologies included with Oracle Autonomous Database, pre-configured, installed, and ready to go right out of the box. This audience is, I imagine, is familiar with Oracle Apex. It gives you not only runtime low-code apps, nicely deployed and ready to use, but also a whole suite of very helpful developer tools, administrator tools for setting up and administering your low-code apps. So I'm not going to dwell on that quite yet. We'll circle back to Apex in a little bit. Also, right out of the box, Oracle Autonomous Database, excuse me, includes Oracle REST Data Services, or ORDS. I'm going to just call it ORDS for short. Maybe you've heard of that. If you haven't, it allows you to set up custom REST endpoints on your database data. And you can even have ORDS automatically create REST endpoints for you on particular tables or views that you select. Also, Autonomous Database has out of the box a standard REST endpoint we call REST enabled SQL. And that allows you to send really any SQL statement to your database over REST and then get back JSON formatted results. So that's kind of another nice feature. It's there and pre-configured for you. And then the third thing that ORDS provides is something we call database actions. And this includes a couple different things. There's a very nice web-based SQL developer IDE, very useful for authoring your SQL statements, your PL SQL scripts, doing a little bit of debugging and executing them. And it has a nice UI for loading data, for managing database users and more. Excuse me just a second. So those are some key things you get from ORDS in Autonomous Database. And all of this stuff, by default, appears at a domain that we set up for you. It's called oraclecloudapps.com, and using an Oracle provided certificate as well for that domain. And that's widely used right now and very useful for, we've got many use cases, but for example, employee facing apps where, running it at the default domain and certificate is just fine. You don't necessarily need to be promoting your app to your own employees in the browser address bar at all times. So it's, many folks are happily running their apps and the REST endpoints on this domain. And we're going to talk about how to change that, and we'll show you a demo. We'll show you an example of how to change that if you need to. All right, before we do that, I want to talk a little bit about other things you get in Oracle Cloud Infrastructure. And there's a lot of very useful, very complementary services available in OCI. Here's some of the networking resources you get in OCI, and you can link these up to Autonomous Database in useful ways. This includes things like virtual cloud network, security lists, security groups, internet gateways, VPN, Fast Connect, load balancer. We'll be talking a fair amount about load balancer. These are all very complementary network building blocks that can be employed to adapt and extend what your Autonomous Database can do. So if you remember nothing else from this presentation, this is probably the most important point. I'll kind of start with the punchline. If there's something you're looking for your Apex app in Autonomous Database that we have not yet packed directly into Autonomous Database, it's quite possible that you can configure that using these building blocks yourself. There are many examples of that. This Vanity URL configuration is one of them that we'll be talking about in some detail. Now, all of these services, most of them are available at no extra cost. For the ones that are paid services, generally there is a small always free shape available, or they're available at some very modest extra cost. For example, if you're using load balancer lightly, there's a nice always free shape available for it. If you're using it a little more heavily, you could be paying a couple dollars per month or even pennies per month, depending on how lightly you're using it. If you're using it heavily, then there's obviously some costs associated with it. But most of these things are just free, always free, or available at very modest extra cost. So take a look at these things, and I'll be showing you some of them here in the demo. Okay, so now let's get into Vanity URLs. This is a new approach to configure and deploy a custom domain name on your Autonomous Database that we just launched this fall, actually in September, so it's about 2.5 months old now. And this is quite useful for folks who are using Apex, not for employee apps and things like that, but they're actually standing up SaaS apps that are facing the general public. Or perhaps you're an ISV who's standing up that kind of app on behalf of one of your clients. This is a very legitimate requirement where you actually want to see your own domain name and use your own certificate, and you want that stuff visible at all times because you want to promote your own brand identity. And of course, that's a very real requirement for Apex apps, but also for ORDS REST endpoints. You're standing up endpoints that may be used by other developers, and you want to kind of promote yourself. You want them to be accessing those endpoints using your own domain. So that's the use case that we're going after here. And this capability leverages a feature of Autonomous Database called private endpoint that gives you a private IP address. So that is something that's required here, and we'll show you how to set that up. This is a feature that's available with all paid Autonomous Database instances. It's not available for the always free Autonomous Database instances, but it is available for any paid instance. And we're going to set up ADB with a private endpoint and then use it in combination with some of these OCI networking resources, especially the load balancer. And I'll show you how to configure a load balancer. One key advantage of this approach is that it keeps the stack fully autonomous. We're not really taking over anything and attempting to do anything in a kind of custom manner. We're all using just very standard building blocks that Oracle maintains. Autonomous Database is something that Oracle manages, monitors, troubleshoots, tunes, patches, periodically upgrades. We do all of that for you. And similar story for the networking building blocks that we're going to be talking about. They're fully managed things that Oracle takes care of for you. So by assembling the building blocks in this manner, it keeps your stack fully autonomous. It's kind of I guess the way to think about it is one and done. You spend a half hour setting it up, and then for some very long period of time, you don't really need to worry about it. Oracle is taking care of the stack for you. So that's a very key benefit of this approach. Now you may be thinking, hold on, wait a minute, back up a step. Didn't Oracle already support a capability to stand up my own custom domain name or my own Vanity URL? And that is in fact true. For some time, we've had this feature called customer managed ORDS. And what this does is it allows you to take the shared middle tier that comes out of the box with an Autonomous Database instance and take over that middle tier for yourself and create your very own dedicated middle tier running ORDS. So we've had that capability for a while now. And I wanted to compare and contrast the two approaches. They both have unique strengths, unique benefits. With customer managed ORDS, this supports not only paid autonomous databases, but also the always free autonomous databases. You can do this with virtually any type of autonomous database, free or paid. And it provides full control of the middle tier. There's some advantages of this. You get all the power and flexibility of owning your own dedicated middle tier. You can not only set up your own custom domain names, but you can control the database connection pool and do all kinds of other things that you may want to do. And we have many customers who are using customer managed ORDS happily and doing these sort of things. Now, on the other hand, Vanity URLs has some distinct benefits too. It supports the autonomous database workload type Apex. So within Autonomous Database, there's actually 4 distinct workload types. There's the transaction processing workload type, which, as the name implies, is for transactional and mixed workloads. There's the Autonomous Data Warehouse workload type, which is for data warehousing and analytic workloads. There's the JSON database workload type, which is for JSON type workloads. And then there's a 4th workload type, which is really all about Apex. Apex comes pre-configured, ready to go out of the box with all of those workload types. But then there's a unique one specifically for Apex, where we turn off some of the non-Apex type features in Autonomous Database in exchange for offering that workload type at a greatly reduced price. So you get it at a fraction of the price, but the focus is specifically on Apex. Now for that specific workload type, the Vanity URL configuration works great. It works for all the Apex on all the workload types, but customer managed ORDS does not work with the Apex workload type specifically. It works on the others, but not the Apex workload type. So that's a distinct strength of the Vanity URL approach. And as I mentioned, the Vanity URL approach keeps the whole stack. It keeps it autonomous, right? Not only the middle tier, really, the database, the networking. You're dealing with all fully managed resources. Whereas with customer managed ORDS, you're taking over that middle tier, and along with that, you are taking on an obligation to keep it patched, keep it upgraded, monitor, manage, troubleshoot. And you're doing that not only for ORDS itself, but for the host operating system, in your VM, And for the Java server, J2E, the Java server, you need to take over those things and do those yourself. Again, we have many customers who are doing that for specific reasons and are doing it very happily. So Customer Managed ORDS is a great solution in those scenarios. And Vanity URL is now a second alternative. So with those things in mind, pick the approach that meets your business requirements. Okay, a couple important prerequisites before we dive into the Vanity URL approach. First of all, it helps to have some familiarity with this stuff. Autonomous database, networking, load balancer, and I put a little link there to the documentation if you want to brush up on it. So some familiarity helps, makes it go quicker. Maybe instead of half an hour, it takes you 15 minutes, right? It does help. I want to point out that being a super expert on these things is not required. A normal person can do this. You don't have to be a super guru expert to do these sorts of things. And you'll see in a moment, we'll do this together. But having some familiarity helps. You need to have an OCI tenancy with access to a specific region where you want to deploy. You need to have an OCI account in the tenancy, and that account needs to have privileges to create database and networking resources. If you sign up for OCI free tier and get a tenancy and account through the free tier sign up, then you have all these things by default. Don't necessarily need to worry about granting extra privileges and things of that nature. You'll have these things by default when you sign in with your default administrator account. But if you're using someone else's tenancy, you're in an enterprise situation where your enterprise has tenancies. There's some information about this in the links I'll provide later, but you may need to request some privileges to create these resources. But if you're free tier, you probably have what you need right out of the gate. You also need to have ownership of a domain name. Obviously, whatever the custom domain name is, you need to own and control that. You need to have a matching SSL TLS certificate. I'm not going to go into a lot of detail on those two things. We'll assume you're somewhat familiar with domain names and certificates. And then lastly, you need to have the ability to create DNS records for the domain. And I'll actually show that. That's kind of the final step of the demo that links everything up together. So you can resolve the public IP address of your load balancer to the correct domain. So you need to create a DNS record for that. The approach to set these things up is it's about 4 key steps, and at the end, test and verify. We're going to configure some OCI networking resources. We're going to create an autonomous database with a private IP address or a private endpoint. We're going to create and configure a load balancer, and then we're going to create that DNS record at the end that points to the right place. So those are conceptually, those are the high-level steps, and then at the end we'll show it working. Okay, with that in mind, I'm going to actually switch over to the browser now. I need to share something different. Give me just a second. Okay, here we go. So hopefully you can see my browser now. And this is a high-level diagram of where we're going. So we're starting with the end in mind. This is what the high-level architecture looks like. We have our Apex apps, Apex app builders, or excuse me, Apex app builder users and app users, both developers and end users. We have our database action users. We have systems that are calling our REST endpoints. This is all on the left-hand side. So these are kind of like our end users, right? And on the right-hand side, we have our configuration. It'll be in a particular cloud region. We'll have a VCN created and 2 subnets within that VCN. And in the private subnet, that's where we're going to plop our autonomous database. That's where we're going to put our autonomous database. We'll attach some ingress and egress rules to that. In the public subnet, that's where we're going to put our load balancer. We're going to attach some ingress egress rules to the subnet in that case. And then finally at the top right is our DNS, and we're going to set up a DNS record to point everyone to the right place. So this is what we're driving towards. And I'll refer back to this as we're busy configuring. So we'll kind of see each step as we're configuring it. Okay, so I'm going to start off here at the OCI console homepage. Hopefully you can see this all right. So this is just the homepage in a browser tab. Immediately after you log into OCI, this is the page you see. And we're going to start off by going to OCI networking. Click here. This thing on the top left is called the mega menu. This is your gateway into everything that OCI does. This is where you get to the respective consoles for the respective services. So I'm going to go to networking, virtual cloud networks. We're going to do this all live. So there might be some delays here as pages are refreshing and resources are being provisioned. Looks like we've got it now. Okay. All right, so this is the VCN. This is the virtual cloud network, and I've pre-configured this. I set it up beforehand. The key thing when you're creating a VCN is setting the IP address range. And I've done this in the form of an IPv4 CIDR block. So in this VCN, I've said it's going to be at 100.0, and it's going to dish out a bunch of IP addresses underneath that. So I've specified the block for my VCN. And that's the key piece of information. And then within the VCN, you can see I've pre-created, give it a second to refresh there. Okay, I've pre-created 2 subnets. One is ADB net, Autonomous Database Net. So this is where we're going to put our autonomous database. And the block for that one is 100.0.1. And I've made that a private subnet. And then the other subnet is LBR net. That's where we're going to place our load balancer. And I've made that 100.0.2, and that's a public subnet. And so you may ask, well, what's the difference between a public and a private subnet? Well, the key difference is that when you designate something as private, you will not be able to successfully put resources in a private subnet that are supposed to have public IP addresses. So by having it in a private subnet, you're effectively prohibited from having resources in there that have a public IP address. Whereas with a public subnet, you can put resources in there that have a public IP address. So that's the key difference. And you want to make sure to select this when you're creating the subnets, select those appropriately. So now we've got a VCN, we've got 2 subnets. So I'll go back to the architecture diagram. That's these dotted lines here. VCN is the outer one and the subnets are the inner. One's public, one's private. Let me show you a couple of the things I've pre-configured here. Network security groups. So I'm going to attach this directly to my autonomous database when we create our autonomous database. And this gives me the ability to set some ingress and egress rules. And you can see here, I've set up some basic ingress and egress rules. On the ingress side, I'm going to allow traffic in from 100.0.2. So I'm going to allow traffic in from that subnet where the load balancer is going to be, but no traffic from anywhere else. And I'm going to allow traffic on 443. We're going to use SSL TLS. And on the egress side, I'm going to allow basically anything back out for connecting back out to the outside world. Now, you can certainly get more specific, more narrow with these rules if you like. My intent here with all this is to just give you a kind of basic configuration to start with. All right, so that's the network security group. Let me show you a couple other things here. Let's go to the security list. So with the load balancer, what I'm doing, instead of using network security group for the load balancer, I'm using something called security list. This is probably more widely used in Oracle Cloud just by virtue of the fact that it's been around longer. And you can attach these security lists to the containing subnet. Network security groups are probably the more contemporary way to do it, but they're a little newer. They're a little less widely used right now, but their network security groups are kind of the go forward way to do this. But since security lists are still widely used, I wanted to show you an example of that as well. So I put a security list for the load balancer, and that is going to be protecting the public subnet that the load balancer resides in. And in this case, I'm just taking the default security list that was created by default when I created the VCN, and I'm making some subtle but important changes to it. So I'm going to drill into that default security list. And here's the ingress rules. Again, this is public, right? This is public facing. I want the public internet to be able to communicate with my load balancer. So in this case, I'm allowing anything in on port 443. And for egress, I'm allowing it to make whatever connections it wants back outside to the outside world. So again, some basic security rules to start off with for your load balancer subnet. You can get more narrow if you like. This is kind of a basic set to start you off with. All right, so that's the security list and network security groups. And let me show you the internet gateway. So you need to have an internet gateway. This is really easy to create. You're basically just giving it a name, and then you need to reference your internet gateway inside of the route table. And for this, again, I'm just taking the default route table that was created for the VCN when it was provisioned, and I'm making one change to it. I'm adding a route rule that maps the internet gateway. So it's saying any outbound traffic in the VCN, send it through the internet gateway. All right, so one rule there to reference the internet gateway. And let me see if there's anything I've missed here. I don't think so. So that covers the subnets, the VCN, security list, network security groups, internet gateway, and route table. Okay, so now if we go back here, you can see where we've got the security list on the public subnet. The network security group is going to be attached directly to the autonomous database. So we've got these key things in place. So now let's go to the next step. This is where we're going to actually create our autonomous database. If I go back to the mega menu and navigate to autonomous database. Okay, so before I do this, you can see here, I've already got a public one sitting here. So I pre-created a public one just because I wanted to show you a few things first. Let me show you this. So this is public, right? So this is just a demo. It's outside of our architecture, just for the purpose of showing you what a few of the links look like. Normally, if I drill into autonomous database, I go to tools, I click open Apex. Let me share a little bit more with you so you can see the address bar. So normally Apex is going to appear on a URL that looks like this. All right, so this is just a regular public autonomous database. And you can see oraclecloudapps.com. This is the domain name where it appears, and it uses an Oracle certificate. And similarly, if I wanted to go to database actions, there's a little shortcut to database actions. Here I can sign into database actions and see all those helpful tools. But you can see it's also at the oraclecloudapps.com domain. And if I configured some REST endpoints, those would also be at the oraclecloudapps.com domain. So that's the way things are by default when I just provision a generic autonomous database. Okay, so we're going to adapt that and do this Vanity URL configuration. And my first step is to create a new autonomous database. We'll call it Van URL ADB. We'll call, this is a name for the underlying database, Van URL ADB DB. So I'm going to give it a display name. I'm going to give the underlying database a name. I'm going to select the workload type here. These are the 4 workload types that we talked about. I'm going to provision an Apex service. In this case, I'll use the Apex workload type. This is the one that's slightly narrowed functionality in exchange for getting it at a fraction of the price. And it still has everything you need for Apex in it. Here, we'll just use the shared infrastructure version. This is all the shared infrastructure version of autonomous database. Dedicated infrastructure version, perhaps that's an office hours for a different time. Here we're focused pretty specifically on the shared infrastructure version. I'm going to use one CPU. We'll start with 1 terabyte of storage. I need to give the default database administrator account a password. So this is the default admin account that gets created with all autonomous databases. And this is important. You got to remember what that password is. And here is a very key selection. This is where I want it to be a private endpoint. Private endpoint is what makes this all work. So I want it to be private endpoint access only, and I'm going to put it in that private subnet. And once I've selected that, I need to select the appropriate VCN. This is the VCN we created earlier. I'm going to select the appropriate subnet. This is that private subnet that we created earlier. Sure, I'll give it a hostname prefix 2, Van URL ADB, something like that. And then here is where we select the network security group. So this is the network security group I referred to earlier with the ingress and egress rules, license included. And then down here, we send automatic emails out to the tenancy administrator, which in this case is me. And if you just sign up for a free tier account, you're the tenancy administrator, you'll get the automatic emails by default. And they're emails like that say things like the autonomous database has been provisioned successfully, or the autonomous database has been terminated. You get lifecycle emails that notify you of key events pertaining to your database. So if you want other people to be notified as well, you can enter their email addresses here. I'm going to just skip that. Let me just review. I think this looks good. Again, remember, a key thing here is private endpoint. I'll click create. And now typically, in most regions, it takes between 1 and 3 minutes to provision an autonomous database. Sometimes less, sometimes a little more, but typically 1 to 3 minutes. So while that's provisioning, now's a pretty good time for questions. Let's pause for a minute or two. And Mark, how is the chat looking? Do we have any questions?
Well, a bunch of questions there. I guess first up, and I think you touched on that early on, but what's the extra monthly price for having an Apex Vanity URL on ADB? Yeah.
Okay, so great question. There's a base cost for running a paid version of Autonomous Database. And then this networking stuff that we're configuring on top of that, almost all of it is free. There's no extra cost for your subnet or for your network security group or things like that. Almost all of it is no extra cost. Load balancer, which we'll be showing you in a second, is a paid service, but there's a small always free version of it available, and we're going to use the always free version of it. So you can get away with very little or zero added cost to set this up. Even if you're using a paid instance of load balancer for heavier traffic loads, still very modest extra cost.
All right. Oh, thank you. And then also, what are my ongoing maintenance responsibilities for this Vanity URL solution?
Okay, another great question. So this particular solution is the one that keeps the stack fully managed. It keeps it autonomous. We're just using the standard building blocks that Oracle patches, monitors, maintains. And to contrast that with customer managed ORDS, customer managed ORDS does have some distinct benefits. It gives you more power, more control, but that does require ongoing maintenance, ongoing management. The patching of the OS, the Java server, ORDS itself, that's your obligation with customer managed ORDS. Patching it, monitoring it, troubleshooting it, maintaining it, periodic major upgrades for those 3 key things. Those are your responsibility with customer managed ORDS. So that's an important decision point you got to weigh when you're choosing which one you want to use. Do you want the extra power and flexibility of customer managed ORDS along with the extra obligation to maintain it? Or are you okay with just a custom domain name and keeping the stack fully autonomous? That's a key decision point.
All right.
All right, it looks like I'm going to move on now. It looks like this is finished provisioning. So now we have our autonomous database. It's up and running. It's live. And here, if I go to Tools and I click Oracle Application Express, you'll see it's saying, well, hey, hold on. This is a private endpoint, and it's in a private subnet. So it's not going to immediately open it at the standard oraclecloudapps.com domain. It's going to kind of inform me that there's some extra steps I need to do to configure it because it's private. The key thing here that you need to know, and I'm going to copy this to the clipboard, is the private IP address. So we can see it's under 100.0.1. That's my private subnet. And it gave it the IP address 198 underneath there. So I'm going to copy that because we'll use it later. And with that, we have an autonomous database. Let's move on to setting up our load balancer. So referencing the architecture diagram, I've now filled in this bottom box with an autonomous database and a network security group pointing to it. I'm now going to move up to the upper box and fill in the load balancer. We'll go back to our mega menu, and I can just go to networking, load balancers, and probably, many people in the audience today have fooled around with Oracle Cloud. We probably have folks who've fooled around with Autonomous Database or are actively using Autonomous Database. This is the piece that's net new. This is probably the piece that's a bit new for most people. So I am going to go through this step by step. So you get familiar with load balancer and you understand how to provision a load balancer and configure a load balancer. I'm going to dwell on this a little bit. We'll go through this step by step. So first thing I do is I navigate to the load balancers area. One other thing to point out. I'm putting all my resources together in the same compartment. And compartments are an important concept in Oracle Cloud as well. This allows you to group resources together and assign permissions and privileges to them. So any administrative user who's coming in through the console, or developer who's coming in through the console, or if you're just accessing these using the public REST APIs, you have to have certain permissions that are dictated by the compartment. So I'm grouping these things all together in one compartment. So if you want to configure anything in this little stack, I could, for example, just assign a group to this compartment. If you're in the group, you have access to tweak the configuration. The compartments are very useful for grouping cloud resources together and assigning permissions and privileges to them. So I'm going to stay in Vanity URL demo compartment. Okay, so we'll click Create Load Balancer. And there's actually two types of load balancers available. There's a level 4 load balancer, layer 4. So it's a little lower level. And then there's the regular, that's this one, right? Layer 4 pass-through load balancer. But the one we want to use is the HTTP load balancer, layer 7. So we want to use this standard load balancer, HTTP. That's a key choice. Make sure you select this one. Say Create Load Balancer. And then it's going to take me into a little wizard that will walk me through this. First, I need to give the load balancer a name. Call it Van URL LBR. I want to select public. This is what gives the load balancer a public IP address versus keeping it private and only giving it a private IP address. So this is what's going to face the public. This is what's going to face the internet. So I want it to have a public IP address. I'm going to just have it grab an internet address out of the pool. I'm going to go with this flexible shape. I'll go with 10 max, 10 min. This is megabits per second. So this is the bandwidth. And if I just leave this at the defaults, 10 and 10, this happens to be the always free shape. This is the always free shape of load balancer. So by provisioning this particular shape, no added cost. I'm going to go with that. And then down here, this is where I'm going to select our VCN. This is what we talked about earlier. And within the VCN, here, I want to put it in the LBR subnet, the public subnet. So this is one of the other subnets we talked about. So that's an important selection, VCN subnet, public IP. I'm just double checking here before we move on. So I think I've got that one ready to go. We'll go to the next step. And here it's asking me about the back end. What's going to be behind this load balancer? And the load balancing policy, weighted round robin is fine. We're actually only going to have one server behind our load balancer in this particular demo case. So weighted round robin is fine. I'm going to skip this add backends for now. We'll circle back to that in a moment, and we'll go through a fair amount of backend details. So I'm going to just skip that for now. And then the health check. So this is where the load balancer is pinging the back ends that you've set up and making sure that they're alive and okay. And we want to use HTTPS. I'll change the port to 443. And we want to check for status code 302. We do some redirecting behind the scenes inside of Autonomous Database. And the status code that we're frequently returning is 302. That's found in HTTP language. So that's the status code I want to check for my health check. I'm going to skip this use SSL for now. We'll circle back to that as well. But I do want to open the advanced options, and I'm going to create kind of a shell empty backend set. VES, we'll call it. And we'll circle back and fill in the details for this backend set. We'll put a backend server in the backend set. We'll do that in a moment. For now, I just want to kind of create an empty shell. All right, so let me review that, make sure that looks good. Robin looks good. So let's move on to the next step. And here I'm going to create a listener for the load balancer. Van URL, give it a name. I want to select HTTPS 443, yes. So this is what's going to be listening on the public internet for inbound connections from people on the public internet. And as such, it needs to know my certificate for my custom domain name. So this is where I specify the certificate for my custom domain name. And it turns out OCI has a centralized certificate management service. You can use that, or you can just have load balancer manage the certificate. I'm going to let load balancer do it for now. And this part, I need to Alt-Tab over, and I'm going to drag and drop files from my certificate bundle, which I received from my certificate issuer. And I'm going to start dragging and dropping them here. So you'll see exactly what I'm specifying for my certificate information. It'll just kind of appear. Okay, so the first thing I want is my SSL certificate file. There we go. Second thing I want is my CA certificate. That's called chain only in the bundle that I received. And then I'm going to drag over my key file. So you saw those appear. And I'm going to do all this on a sample domain called tbottger.com, toddbottger.com. This happens to be a domain that I own, that I'm effectively donating to my employer, to Oracle Corp, for demo purposes. So this is the domain we're going to use for this example. So here's the certificate information for it. I think this looks good. Everything looks good here. So now we'll move on to the final step. Now this is where we specify logging. Load balancer has some very nice web logging capabilities. And in a production deployment, yes, you definitely want to leverage the logging. You want to leave logging on. And this can ship logs over to a centralized logging service that's available in OCI. That logging service has some nice analytical capabilities. You can see what's going on. So in a production environment, yes, I want to enable logging. I want to ship the logs over to the central OCI logging service. But for demo purposes, just to keep things simple, I'm going to turn that off for now. Okay, and that's pretty much it. That is how we create and configure a basic load balancer. So we'll click submit, and that's going to take a minute or two to run. We'll let that refresh. You can see it's creating. Scroll down. Okay, so it's basically creating right now. It's going to take a minute or two for that to complete. So Mark, now is another good time for a question or two. Do we have any other questions queuing up in our chat?
We sure do. So I guess one on the list here is what's the difference between autonomous database and Apex service, and do Vanity URLs work for both?
Okay, yeah, another great question. This configuration that we're doing right now work for Apex service. It works for autonomous transaction processing, autonomous data warehouse, autonomous JSON database. It works for any of the workload types of autonomous database shared. And again, just to be clear on the difference, they're all workload types underneath a common autonomous database solution. They're all standard workload types. The key difference between the Apex workload type and something like autonomous transaction processing or autonomous data warehouse is that it drops some of the core non-Apex functionality that you normally get in autonomous database in exchange for a much lower price. You can get it at a much lower price. So, and Vanity URL works for both or all of these ADB workload types.
All right.
Okay, so that answers that question. Any others?
There are more, sure. I guess one is about whether it's possible to create distinct Vanity URLs for different Apex apps or different Apex workspaces running on the same ADB. Okay,
that's another great question. And the answer to that question is no, actually. So the way this is set up, it's one Vanity URL per ADB instance. And if you have multiple custom domain names where you want to run Apex apps running on autonomous database, the way to do that is to have distinct autonomous database instances. But on a single autonomous database instance, using this configuration, it only supports a single Vanity URL for now. That is something we're looking at. I want to point out too, that is something we're looking at going forward. So stay tuned. We might extend that in a future release. As things stand right now, when you set up this stack, you get one Vanity URL per autonomous database instance.
Right.
Okay, so it looks like this finished provisioning says active. It'll take a sec, maybe a few minutes even, for this health check to run. And then this thing that says incomplete, it'll change to green the next time it does a health check. And but before we do that, we actually need to give it something to ping. So we need to fill in the backend set and the backend details. Looks like now the basic load balancer is in place. Okay, so let's drill into backend sets. Remember, we created a shell backend set. There it is, Vanity URL BES. And I'm going to configure that. So drill in there. Okay, we're in our backend set. And I want to go to edit. So here is where I'm going to tell load balancer that I want the backend to use SSL. I want that backend connection to be an encrypted connection. As you may recall, there was a checkbox for that in the wizard. I skipped it. I'm going to set it here, use SSL. So that backend connection between load balancer and autonomous database, which is all inside of Oracle Cloud. These are all Oracle Cloud services inside Oracle Cloud. I'm going to tell it that I want it encrypted. Now, because it's Oracle to Oracle inside our own data centers, that's a trusted connection by default, actually. I don't necessarily, it doesn't, in this particular case, it doesn't really care what certificate I select. I'll just select whatever, the same one I used for the load balancer, because it's not really going to be used. The key input here is just telling it to use SSL at all. And then because it's Oracle to Oracle, it knows how to do that. It's a trusted connection. It doesn't so much matter what particular certificate I select in this case. But I want to make sure I do alert it to use SSL. So I'll do that and save changes. Okay, so let me explain this a little bit. OCI has a nice framework for managing these work requests. When you make a config change, it goes into a work request queue, and then OCI starts chugging away at those work requests. So when I made that change, it went into the OCI work request queue. I saw it work on the work request, and now the work request is succeeded. So that config change is now committed. So that's what work requests are. And you want to make sure that the work request is green succeeded, before you move on. Close. All right, so now I've done some basic configuration on the backend set, and I want to drill in and actually add a backend server to the set. So I'll drill in here, I'm going to click Add Backends, select IP address, and this is the private IP address of my autonomous database. Remember, I put that on the clipboard. I'm going to specify that private IP address. I want to use port 443. And now I'll click Add. So now I'm adding my backend autonomous database to that backend set. So I'm giving my load balancer its backend. Again, a work request goes into the queue. OCI starts churning away at that work request. And in a second, this should turn to succeeded. And we'll know that the backend is there. Yep. Okay, good. Here we can see the backend listed now down here. All right, so this looks pretty good. And again, when the health check starts running, this should turn to green. Right now it's still yellow. So it says pending, and ultimately it'll return to green. Okay, so now let me go back here. So I've filled in my bottom box with the autonomous database. I've filled in my upper box with a load balancer. And then this solid line connecting the two right here, that's the private IP address of the autonomous database. I just added that as a backend server to my load balancer. I uploaded my certificate information to the load balancer. The very last step now is to go to my DNS, create a DNS record. And in order to do that, I'm going to need, let me go back to load balancer details. I'm going to need my load balancer's public IP address. So let's go grab that. Control C, I'm going to put that on the clipboard. And okay, so here is my personal domain name reservation service. Maybe some of you have seen this. I'm just using Namecheap. No endorsement for that one implied. but this just happens to be the one that I'm using personally. You can see my tbottger.com domain, and I don't have any DNS records for it yet. So I need to create a DNS record, create an A record that will point to the public IP address of my load balancer. And this is important. So let me just go double check that. 132.226.132.226.30.31. 30.31. Okay, so that looks good. And this has gone to green now, by the way. See, it says okay, green. That means it's the load balancer is alive and it's successfully communicating with the back end now because the health check is succeeding there. All right, so this last step is setting the A record. And when I click the checkbox here, that record is going to start propagating. That may take a few minutes depending on where you are in the world and what DNS you're using. In this case, I've found mine usually takes a minute, 2 minutes, maybe 3 minutes. Sometimes it's like almost immediate. There may be a little delay here. You may need to wait here for a couple of minutes, maybe even an hour or even a couple hours, depending on where you are in the world for this to propagate. I think in this case, it'll be pretty quick. At least it has been in my dry runs. So, okay. So that DNS record is now there and propagating and percolating out. So within a couple minutes, hopefully I can go right to my custom domain name, tbottger.com, and I can get to Apex. So I've just filled in this last part, this dotted line up at the top. It's tbottger.com DNS. Okay, so let's give that just a minute before we try it once. And Mark, just looking at the chat box, do we have any other quick ones we could cover while we're waiting for that?
Yeah, I think a bunch of questions around pricing. So one is, why isn't private endpoint in a VCN available for always free ADB? It kind of defeats the point of the earlier mention that you can use an always free load balancer if you're paying for ADB.
Well, for free autonomous databases, you can, when you're developing your Apex apps, you're kind of in the development and test phase for your apps. You're welcome to use the customer managed ORDS, right? You can actually get a Vanity URL or a custom domain name using the customer managed ORDS approach on a free autonomous database. So there is a way to do that. But when you go into production, I wouldn't recommend using an always free instance for production, right? In the first place, you want to have a paid instance with a support contract and an SLA. When you're into production, you're probably on a paid instance. So you have the ability to use private endpoint at that point, and that's when you can configure these other building blocks to get the Vanity URL. And the other building blocks, very modest, if zero extra cost on top of that paid autonomous database. So there are things you can do with an always free. And then when you get into production, you're using a paid autonomous, very modest extra cost at that point.
All right.
Okay, let's give this a try. Let's just see if that DNS record has propagated out there. And let's try and share the browser address bar here. So now, instead of that really long URL that we saw before, if I did all this right, in theory, I can just go to tbottger.com and I should see Apex now. Oh, okay, so now we can see, right? I went to tbottger.com. It's now no longer oraclecloudapps.com. And I got this. So initially with a brand new autonomous database, we always show you the admin services login and prompt you to create a workspace. That's the first thing you always see. So I'm going to actually do that right now. Make sure I remember my password. Okay, it signed me in to Apex Admin Services. Looks good. We prompt you to create a workspace. Let's create basic developer workspace in Apex. Give this a password 2. Create workspace. So far, everything's looking good. Apex is running great at my custom domain name, and I've even created a workspace for it. Let's log into the workspace. Okay, for this next thing I want to show you, I'm going to take this all the way across the finish line here. I'm actually going to create an Apex app. We'll just use the wizard I'll do like the simplest case. We'll use some of the packaged sample data and use the project and task data, and we'll create a little sample table and sample Apex app. Call it projects. All right, so it's creating a table and loading the sample data. That'll take, usually that's pretty quick. There we go. And then on top of that sample data and sample table, now I'm going to create a sample Apex app. Very easy to do using our wizards. Okay, here we go. Just call it projects. I'll throw the whole kitchen sink in here. We'll throw in all the features. Click on create application. So now this usually takes a minute or two as well. We'll see how long. In the meantime, Mark, while it's creating my app, anything else coming through on the chat?
Well, I guess, is there a way to automate certificate renewal on a load balancer?
Is there a way to automate certificate renewal on a load balancer? I believe there is in the centralized certificate management service in OCI, but I'm not quite sure on load balancer. I need to check that. So let me take that as an action item. I'll check that to how do you automate certificate renewal. So if you're using Let's Encrypt or Acme or something like that, how do I set that up so it's doing it for me? I'll check on that.
Sure, thanks.
Okay, so it looks like we have our Apex app up and running. And normally you can just click on Run Application. You can see the developer view of your Apex app. Or I can, let me show you another. So if I go to Edit Application Properties, here's our application alias, projects. So if I log out of App Builder, and let's just go to the runtime app. So I'm going to dump that. And on ADB, there's a standard way to get to the runtime apps. It's /ords/r, and then schema, and then the app alias, projects. So this should show me my runtime app. Yep, and there it is. And it's all at the Vanity URL. So at this point, we're looking very good. I got my runtime app. I also have access to Apex workspace login. I can get to App Builder. I can get to database actions at this as well. Let me show you that. If I go to ORDS, I'll just use the admin schema. Or actually, I'll just take a shortcut, SQL Developer. So this is the database actions login. You can see this is also at my Vanity URL. So at this point, you may be asking, okay, great, everything's working at my Vanity URL. Everything looks good. It took about 20 minutes, 25 minutes to configure that, but it's kind of a one-time thing. I'm all good. However, there's one important point. What if I want to restrict this a little bit? I want to lock it down so that not just anyone can go to the Vanity URL and access the Apex workspace login, sign into App Builder, and start making changes. I really only want to expose the runtime stuff, not the developer and administrator stuff. So how do I tighten this up a little bit? How do I lock it down a little bit? So at my Vanity URL, I can see runtimes, but not administrator and developer tools. So I'm going to show that really briefly, and then we'll kind of end on that note. And the good news is, now that we have a load balancer in front, let's go back here. Demo project. Oops, forgot ORDS. We always put ORDS in the path too. Even if you just go to the base URL, we'll redirect so that ORDS is in the path. So here's my runtime app. I want to show this runtime, but I don't want to show the Apex workspace login. So the good news is, because we have a load balancer in front, we can leverage that with some really simple load balancer rules that on the server side will do some redirecting and will help us lock things down and tighten things up. Now, once we do this, I will no longer be able to, through the Vanity URL, no longer be able to get to the workspace login. But there are other ways to get into the private endpoint. And I'm not going to go into a lot of detail here. It's well documented. You can bastion into the private endpoint. You can fast connect into the private endpoint. You can VPN into the private endpoint. You can do all those things. So you still have ways for developers to go in and develop Apex apps. But at the Vanity URL, I'm going to close off that workspace login with the Vanity URL. So we'll use some what's called rule sets to do that. So I'm going to create a little load balancer rule set. And we'll give this a name. We'll call it ADB public access. And inside of load balancer, I want it to do some server-side redirecting. First thing I want to do is, instead of attempting to show the workspace login by default, I want it to show my default Apex app by default, right? So I want to show that little projects app. That should be the default homepage. So I'm going to set up, it's very easy to configure that. I'm going to just set up a server-side URL redirect rule to do this. So anything at ORDS, anything that ends with ORDS, suffix match. Remember I mentioned we always inject this in the path /ORDS. So anything that ends with that, that's my default. HTTPS, my host is tbottger.com. And instead of attempting to show the workspace login, I actually want to show the app runtime. So say ORDS are demo projects, right? This is the link to my runtime app. So it's going to take that default root. When it sees that on the suffix, it's going to redirect to my default app. All right, so now I've given it, essentially given it a default page or a default app to work with. So the next thing I'm going to do is I want to make absolutely sure that Apex never presents any sort of admin or developer tool. And there's a way to tell Apex itself to stop doing that. So there's actually a setting in Apex. And the way we activate that setting is by sending it a header. There's a special header that Apex can look for. You can give it whatever name you want. I'm going to just call it ADB public access value 1. And then I'm going to make a setting in Apex whereby whenever it sees this header, it's going to make absolutely sure you can never access App Builder and Apex admin services and stuff like that. So I'm going to tack on a special header, click create. That's going to create a work request. It'll take it a minute to finish that. So now I've set up some access rules to tighten things up. I have not actually applied them yet. I've just defined them. In order to apply or to deploy them, I need to go into the listener and tell the listener to use this rule set. So I'm going to come back to that in a second. And in the meantime, I want to go to database actions.
But we're already over time a little bit.
Oh yeah, okay. Thanks for the time check. Is it okay if we go another?
Yeah, I mean, go on for a little bit longer. That's just to kind of give you a heads up that we are already past.
We're very close to the end. I think another like 3 to 5 minutes.
Sure. That's perfectly fine.
Okay. All right. So I'll finish this off. Try and do this as quickly as possible. Okay. So if I want to log into database actions, you can just go to this shortcut. And in order to make Apex aware of my special header, I'm going to run a little script in the SQL Developer Web IDE, and that's under SQL. So you get to see the SQL Developer Web if you haven't seen it before. And I'm going to run this script here. I'll give you a second to look at that. Pretty simple. Apex instance admin, perhaps you've seen that before, set parameter. And I'm setting this parameter called restrict dev header. That's the key thing to remember. And then the header name I gave it is Apex Public Access. So whenever it sees that header present, it's going to make sure that you don't get access to Apex admin services, Apex App Builder, things like that. So I'll just run this. And that completes the loop. Now it's executed successfully. I'll sign out. Okay, we're signed out. And let's go back to my OCI page. Okay, here we go. So now I'm going to actually deploy that rule set on my load balancer listener. Say edit, and this is the very last step. Rule sets, additional rule set. It already picked up that I'd created one. Now if I apply that, now I'm deploying the rule set to tighten things up. progress. Close. Okay, succeeded. There we go. All right, so now if I go back to my Vanity URL, let's try this again. We'll just go to the base URL. You can see that now, instead of showing the Apex Workspace sign-in, it shows my default app. I'll end on
maybe two last. So go ahead. I have two last questions to ask.
Okay. Well, while you're doing that, let me just show one last slide that has some links for additional information. So I'll just leave that displaying. Here's some links where you can get additional information. Everything we talked about is blogged about. You can follow the blogs by going here. Lots of helpful information about Autonomous Database, and of course, lots of helpful information on the Apex central site, apex.oracle.com. Okay, I'll leave that displaying. Mark, I think that's pretty much it. Any last questions?
Yeah, so one is Vanity URLs, are they available in all regions?
Yes. Yep.
All right, excellent. And then I guess a more general question about SQL connections. Is the situation with SQL connections to the Apex service likely to ever change? Well, I guess there's additional comment.
Yeah.
Go ahead.
Let me interpret that. So I mentioned with the Apex workload type specifically, you have the key things that you need to develop and deploy Apex apps. But we turn some things off in exchange for getting it at a quarter of the price or a third of the price. So the key thing that we turn off is SQLnet connectivity, Oracle Net Services connectivity, right? That's the key thing we turn off. And there isn't a plan to change that. There isn't a plan to give you the full service at a quarter of the regular price. If you need SQLnet, you can always get that. Just provision the autonomous transaction processing workload type, the autonomous data warehouse workload type, or even the autonomous JSON database workload type. That comes with Apex as well and is available at a lower price. And it does have SQLnet connectivity. It does have a limitation on how much relational data you can store in it. But we do not have a plan to back out the disablement of SQLnet in Apex service and still give it to you at a quarter of the price, right? We have to pay our bills here at Oracle. We have bills to pay. So Apex service, that particular aspect of it will likely remain the same. But if you need SQLnet, there's lots of other ways you can do it. You can go with the full featured ATP or ADW services, or you can even use Apex on autonomous JSON database, right? That gives you SQLnet connectivity. All
right. Well, thank you. And thank you for your presentation. It was great. And recording should be available in a few days. And just a reminder, in 2 weeks, we meet again talking about flows for Apex. So thank you, Todd, and thank you, everyone. And see you soon.
Thank you.
Bye.